Hi there, welcome to my channel. In this video, let's solve this problem. The problem is construct binary tree from pre-order and in-order traversal. So we are given with a two input, two array. One is pre-order traversal of this tree, and second is in-order traversal of this tree. And if you remember the traversal order, in case of pre-order, we do it in root left right, and in case of in-order, left root right. So with this order, we can clearly say that whatever element we have in our pre-order array, the first element is always going to be a root element. And if we get the root element, by finding that root element in this particular in-order array, we'll be able to identify which element is the left subtree and which element is used for right subtree. So if we put that 3 here, we can see 9 will go on the left side and 1527 that is going on the right side. So we are going to follow the same approach recursively and we'll be able to solve this problem. Let's see this diagrammatically once, how we are going to solve it. So we found a root element. We'll create a node first. Then to construct a left side, we need some element. Similarly, for the right side, we need some element. So let's see the right one first. So in order to create the right subarray, we are going to need pre-order array and in-order array. So in pre-order, we just need 20, 15, and 7. And that is this element. Similarly, from in-order, we need 15, 27. And from pre-order, we'll identify that 20 is going to be our root element. So here, we'll take 20 here. From in-order array, the left will be 15 and right will be 7. So if we see the subarray which we took to construct right one, the right subtree, you'll notice that after identifying the root element from the in-order array, we first find the root element, and from there we took all the right elements. Similarly, from in-order, we took it from this index. So we skipped this 9 and we took the rest of it. Now we have to solve this programmatically. So how we are going to identify from which index to which index we have to take it. So here there is a clear indication that after finding the node in order array, we are just taking this length and trying to skip that length from this array. So here the index for this particular element is 1. So from second index, we are taking whole element into consideration. Similarly, if you see for the left side, the pre-order would be 9 and in order is also 9. So how we came to this conclusion? So if you see in this case, for the right case, we took from mid plus 1 and here also mid plus 1 for the right construction. But for the left one, we took mid minus 1 and from here we took mid minus 1. So now let's solve this programmatically. So this is going to be a recursive approach. So let's first do a check here. This is going to be a recursive solution. So let's start it. First, we are going to do a check here. If pre-order is empty or in order is empty, then we are just going to return null. Otherwise, we are going to construct our node. So let's create a node first. We are already given with a function to construct a node. Let's use it. And from the pre-order, we are always sure that first element is going to be a root element. So we'll take first element from there. Then the same element we are going to find in order array. Let's call this mid. And in JavaScript, we can use index of function to find the index of that element. So after doing this step, we'll identify this particular position. Now we have to construct the left subpart and right subpart. Let's see how we are going to do it. So this is a recursive solution. So we are going to call the same function, but the input will change. So here we are going to split our array. We are going to slice our array and we are just going to pass it. We are not going to pass the whole array. So in case of pre-order, we don't need the whole array to construct left subpart. So we'll use dot slice function. And for the left side, if you see, we just need 9. And how we are going to choose it? So from pre-order, we have already consumed the 0th index, so we are not going to pass 0th index. We'll start from 1, and as a end index we need it till mid. I'm going to pass mid plus 1 here, because this is going to give me an array from index 1 till mid. So whatever is going to be your end index, always make it plus 1. And from in order, we are going to slice it from 0th index, and here we don't need mid element because mid element we have already constructed. So we just need till mid minus 1. So I'll do mid here. So the new array will be from 0th index till mid minus 1. So this is done for left subtree. Now let's do the similar kind of thing for right side. So here we'll do it from mid plus 1. We just need from mid plus 1 till the end. So we are not going to pass any second input. That will be considered as the end of the array. Similarly for in order, we'll start from mid plus 1 till the end. So we don't have to pass the end index if you don't have any specific index. So this means that you are taking all the elements from mid plus 1 till the end. So it's done. Now let's return the constructed node. So this is a recursive solution. We are doing this recursively, and at the end we'll get our final tree. There is a typo here. Let's fix it. Yeah. Now let's run it. So the program is successful now. And if we talk about the time complexity, we are constructing this tree, and while constructing this tree, we are creating each node exactly once. So the time complexity would be order of n. So I hope this is clear to you. And in case if you have any doubt, you can ask me in the comment section below. Don't forget to like, share, and subscribe. I'll see you in my next video. Thank you.